Now is the measurement of brake power. Brake power, as in the earlier video, is defined as the brake power is the power that is available in the shaft. The brake power is measured by using dynamometer. Therefore, the brake power measurement involves the determination of the torque and the angular speed of the engine output shaft. The torque measuring device is called the dynamometer. As we can see, this is a rope brake drum dynamometer. You have done a lab in the thermal engineering lab about the determination of load calculation by using a rope brake drum dynamometer. This is a simplified diagram of that test rig. You can see the spring balance, the cooling water jacket, the flywheel, and all these things. As we have done in the lab, you are familiar with this diagram. It consists of a number of turns of rope bound around the rotating drum attached to the output shaft. One side of the rope is connected to a spring balance and the other to a loading device. The power is absorbed in friction between the rope and the drum therefore requires cooling. As in the earlier video, I have given the formula for BP, that is pi d n W minus S, where D is the brake drum diameter, W is the weight that is hang on the spring balance, and S is the spring scale reading. This is the measurement of frictional power. The frictional power is defined as the difference between the indicated power and the frictional power. The following are the methods used for determining the frictional power. One is the Williams line test, Morse test, motoring test, difference between IP and BP. Williams line methods is the method that we adopted in doing lab calculation in the thermal engineering lab. In this method, the gross fuel consumption versus BP at a constant speed is plotted and the graph is extrapolated back to the zero fuel consumption. In the lab, we draw a graph between BP and specific fuel consumption, and extrapolating the graph to the negative x-axis, we get the frictional power. The point where the graph cuts the BP axis is an indication of the frictional power of the engine at that speed. The negative one represents the loss due to mechanical friction, pumping, and blowback. This is the diagram which represents the negative value, which is the frictional torque. Then, on the right hand side of the diagram, which gives the indicated power. Next is the Morse test. This is only applicable to multi-cylinder engine. In this test, the engine is first run at the required speed and output is measured. So that all the cylinders, so consider there is a 4 cylinder is there. Therefore, we get the output of the 4 cylinders during the initial condition. Then we are cutting off one of the cylinder. That is, then one cylinder is cut off by short circuiting the spark plug or by disconnecting the injector. Under this condition, all the other cylinders are in the automatic or are in the working condition. Only one cylinder is not in the working. Say that the first cylinder is not working. Therefore, we get the indicated power of the other 3 cylinders. Then the output is measured by keeping the speed constant at its original value. The difference in the output is measured of the indicator horsepower of the cutoff cylinder. That is, initially we get the total output of the 4 cylinders. Then we are cutting off the first cylinder. Then we get the rest 2, 3, 4 cylinder indicated power of the 4 cylinder 2, 3, and 4. Then we are taking the difference between the total indicated power and the rest 3 cylinders, which gives the indicated power of the first cylinder. Thus, for each cylinder, the IP is obtained and it is added together to find the total IP of the engine. Next, we came across the properties of fluids. The first one is the viscosity. Viscosity is the measure of resistance to flow to the internal friction of the lubricant. Next is the flash point. Flash point, you have done this experiment in the laboratory. That the flash point of oil is the minimum temperature at which the vapor of lubricating oil will flash when a small flame is passed across its surface. Then fire point. If the lubricating oil is further heated after the flashing point has been created, lowest temperature at which the oil will burn continuously for 5 seconds is called a fire point.